Hello, Miss Baynard here with a review video about applying rigid transformations to coordinate points. So there's a points on our coordinate grid here. So let's look at the first one. What are the coordinates of G, H, and I after a 90-degree rotation clockwise? After 90-degree clockwise rotation about 0.00. So 0.00 is our center of rotation. So I actually want to go ahead and put a point there just so we can see it a little better. Okay. And then we're talking about point G. So I'm going to put a point on point G. That way we see it better. All right, so the first thing you're going to do, and this is one of the practice problems from one of the units we did, I believe, in the first week. So the first thing you're going to do is take your tracing paper. So that's here. And you're going to make sure that our points are lined up here. Clockwise is this direction. So 90 degrees clockwise, we're going to go from our x-axis, our negative x-axis. I'm just going to go ahead and put a mark. We'll do that in green. So we're going to go from here, and we're 90 degrees is at our y-axis. So we're going to stop here. Okay. So you can go ahead and move our protractor. You don't need that anymore. And one of the things I like to do is to rotate my tracing paper until my start line, my negative x-axis, is lined up with my end line, my positive y-axis. So I'm going to go ahead and rotate that 90 degrees, but make sure that your center of rotation stays in line. So that's our red dot. So now we have point G, which was located at -1, 3, is now at 0.31. So I'm going to go ahead and write that. So G was at -1, 3, is now at 3, 1. And that's how we rotate a point 90 degrees clockwise on a coordinate grid. So you go ahead and figure out what H and I would be. Okay, so now let's look at number 2. What are the coordinates of, let's look at H. What are the coordinates of H after reflection over the y-axis? Well, the first thing we need to do is probably identify the y-axis, right? So that's this vertical axis here. Okay, so that's going to be our line of reflection is the y-axis. So again, we can use this with tracing paper, but another way to do this is to try to establish a corresponding point. So we can see that H is located at -4, 0. So it is 1, 2, 3, 4 units from the line of reflection on the left side. So H prime, I'm going to go ahead and copy this point here. It's going to be so that means H prime has to be 4 units to the right of the line of reflection. So 1, 2, 3, 4, and we have H prime. So now we have H being reflected over the y-axis, making H prime. Okay, let's look at number 3. What are the coordinates of, we're only going to look at letter I. What are the coordinates of I after a translation of 4 units to the right and 1 unit up? So here we go. We have a point I, and it wants us to translate 4 units to the right. 1, 2, 3, 4. So we're a little bit off the grid here at seven units, right? Okay, and now we just have to go 1 unit up. So that puts us at 7, -1. So I'm just going to put that here. Let's go ahead and add these numbers. So student pick. So this is 5 units on positive on the x-axis, 6, and here is 7. So actually, let's go ahead and fill these in for the other 2 that we missed. So let's see, H is orange. Let's go ahead and keep our colors together. So H originally was at -4, 0. And we reflected it over the y-axis. So it's at 4, 0. And let's go ahead and do I. And I is in pink. Okay. So I was at, let's see, 3, -2. Is now, after being translated 4 units to the right, 7, and 1 unit up, -1. So as you can see, when a point is being translated, we can really just kind of add or subtract, just looking at our ordered pair. So 4 units to the right, that's our x-axis. Going right or left is our x-axis. And right is positive, so we can add 4 to 3 on our x-axis, we get 7. And we're going to go 1 unit up. Up is our y, up and down is our y-axis, and up is positive, so -2 plus 1 equals -1. So this is how we also get 7, -1 is our new location. One thing I want to point out is when we reflect over the y-axis, our x value is the only thing that change, and it becomes its opposite. So H was originally at -4, 0. So after being reflected over the y-axis, it should be at 4, 0. So if H was originally at 4, 0, and we wanted to reflect it over the y-axis, and then its opposite would be -4, so then H prime would be at -4, 0. And the same thing goes for we're reflecting over the x-axis. The y value becomes its opposite. So let's go ahead and look at G. Let's reflect G, and G is blue. Let's reflect G over the x-axis, and G is originally at -1, 3. So if G is at -1, 3, and if we're reflecting over the x-axis, that is our horizontal axis here, then our x value should stay the same, so that's -1. -1, and our y value should become the opposite. Well, the opposite of +3 is -3. And let's just go ahead and try to see. So that's actually G double prime. So if G is here at -1, 3, it is 3 units above the line of reflection, or the x-axis. So it's 1, 2, 3 units above. So then the reflection of G across the x-axis should be 3 units below, 1, 2, 3. And that's here. That is G double prime. And like we said, yep, -1, -3. So that's just a good reminder, just in case you don't actually have a grid to graph your points on. If you're reflecting over the y-axis, then the x value of your ordered pair will become its opposite. If you're reflecting over the x-axis, then the y value will become its opposite.